second half an hour on the 23rd of July, matric class choice 2.
Okay. Right, so going. There are not very many, and I really mean it. There are very few genes. If you look here, for example. Okay? So here, this shows you only the genes that are associated with disorders. Doesn't show you the rest of the genes. And it shows, like, there's chromosome 1, some of the things, there's chromosome 2, 3, 4, blah, blah, blah. These are all the disorders associated with the X chromosome. You see how many there are there? Okay. And then it shows you the disorders associated with the Y chromosome, which is that long. I do have to, there's a disclaimer though. This poster was from 1997, and they've quite probably discovered more things since then. But you can see that there are lots more genes, because the X chromosome is much longer than the Y chromosome. There are very few things associated with the Y chromosome, let alone disorder genes. So if you look there, can you see Carmen? Carmen?
Yes, ma'am.
Can you see it?
Yeah, I can.
Okay. All right, so I would call it a genetic disorder, except if one of them is trying to marry Michelle, who apparently is not going to do this. One of the genes that is on the Y chromosome is hairy ear rims. Ear rims. So this is not hair that is sticking out from the oak's neck because he's been locked down for 6 years. Okay, actually comes from the ear rim.
Oh, it's not from like the middle ear, the outside of the ear.
Outside of the ear.
Imagine how much they pay for wax. Cool.
I think
Okay. Right, so I've put a worksheet onto your thing in Google Classroom, and also the same thing into the general. Just so that you could do a few more sex-linked gene problems. And there are 8 problems here. I recommend you do 3, 4, 6, 7, and 8. Simply because they're very different from the ones that you've done so far. But I've written that in the folder on Google Classroom. So the first one says, suppose a young lady comes to you for advice in your capacity as a marriage counselor. She tells you that her brother has hemophilia, but both her parents are normal. She wishes to marry a man who has no history of hemophilia in his family and wants you to tell her the probability of her children having this disease. What would you tell her? How would you explain your conclusions? Okay. All right, so you're actually doing 3 generations here. You've got to do her parents, his parents, the girl who goes to the counselor and her husband to be, and the possibility of the children. Okay. All right. And her brother. So you would have to work that whole thing. Okay. So I'm just going to leave this as being normal and that one as being hemophilia. Okay, you happy with that? With those symbols? Okay. So the girl says she has a brother with hemophilia, but she is... What are you doing? Because you keep rocking on it. And now you just rock as well.
What about the creed? We can fight, that's what I
Okay. So this girl, the issue is that the girl tells you that her brother has hemophilia, but both her parents are normal. So if her brother's got hemophilia, then he must be like that. Both their parents are normal. Okay, so where did that boy get the allele from? Must have got it from the mother. Okay? So the mother must be a carrier. Okay, and the girl, it says she's normal.
She's normal.
It doesn't say that.
Why she's stressing?
But parents are normal.
Your parents
Yeah,
are
it
normal.
doesn't say.
Okay, so then you can say two things. You can say she's either like this, well, she's got to be normal. Because from the father she's getting that.
Maybe she's a carrier.
The issue is that she has a possibility of being a carrier. And that's the issue in this whole thing. Okay, so the counselor would need to say to her, if she is a carrier, she has 50% chance of producing boys that are hemophiliac. You understand that? If she's like this, but you don't know yet. The male she's marrying is normal. So the male she's marrying is normal. It tells you in the problem. So he must be like that. So this was her brother. That tells you that there is hemophilia in their family. So if she's like this and she marries a normal male, she's got a 50% chance of boy children with hemophilia. Okay? But 50% chance of boy children without hemophilia, and of her daughters, 50% chance homozygous normal, 50% chance of being a carrier. Do you need me to do this?
Yes, please, ma'am.
Okay, so now I'm just doing it with this one. I'm ignoring that one temporarily. Okay, so x to the big N.
I thought those two the same.
I was drunk.
Hey, happy hours.
Not judging.
Yeah, I stayed in teaching all these years. So some sort of classes. Okay. So if it's like that, then it would be like that, and father is doing those two. Okay, so right, so the first cross would be a girl child that is homozygous normal. The second one would be a boy child that is normal, and that's 25-25. 25 would be a girl child that is a carrier, and 25% of a boy child that is... No, who just said that? Michelle.
No, I said it.
Now I know that. Do you understand? Because I've told you boys can't be carriers.
Oh, so only girls can be carriers, but then what would you classify
So
in the
what are we doing? Are we doing hemophilia?
Yes.
So this is a boy child with hemophilia.
So then the girl will be a chance of
She's a carrier.
a carrier.
Yeah. All right. And then if the situation was like this, obviously there's no chance of carriers or children having hemophilia. And that's what the marriage counsellor or genetic counsellor needs to explain to her.
This is completely irrelevant, but I don't know what marriage counsellor would know about genetics.
Yeah. So generally speaking, and listen carefully because it's actually part of your SAGs that you need to know this. So you need to know something about the role of a genetic counsellor. And a genetic counsellor is only allowed to state facts, not give advice. So a genetic counselor would never go, a genetic counselor would explain all of this to her and maybe just say to her options are. She could have amniocentesis done every time she falls pregnant, or chorionic villus sampling, and the possibility could be that she would have, that she could have, if she has falls pregnant with a son that has haemophilia, she could choose to have an abortion, or these are the options nowadays with a child with haemophilia. There is the possibility that gene therapy will work eventually and be able to help the child. There are drugs that work against haemophilia now, so they can give people with haemophilia something called clotting factor, and so their blood can clot normally, etc., etc. So a genetic counsellor simply goes, these are all the options, not don't do this, do that. Okay, it's terribly important that you know that. All right, you okay? All right, this is a really nice one. A man sues his wife on the grounds of infidelity. Both the man and his wife have normal vision, but the daughter has coloboma irisis or something or the other, which is a fissure in the iris of the eye. This is known to be sex-linked recessive. If you were the man's lawyer, could you use this fact as evidence? And if so, how?
Yes.
No.
Because the wife could be a carrier, but then the husband can't be a carrier because he's normal, and therefore she's cheating.
Yeah.
Am I wrong?
I don't know. What do you think?
That makes sense. He has got a point.
That makes sense because then it's not his kid.
Well, who's going no?
I was saying no.
So what's he?
Yeah.
Well, that's what you said, dude.
It's not his kid.
So then he's right.
Oh,
Because Bo was always wrong.
Oh.
It's a fact.
That's so rude.
Don't take that. Wait. Who wants to keep that? I swear it's the
Okay. Do I need to do this problem on the board, guys?
Yeah.
No, man.
Can we see what coloboma irisis looks like?
No.
Oh.
Google it. That's why God
Okay,
invented Google.
yeah, can you do that?
Not now.
When can we do it?
Grandma, what an idea.
Either or, man, we have to choose.
If I choose to do
Need a
this.
picture to match now here of what we do.
What?
We need a picture.
This is gonna be like the grease.
So wait, the moment
Okay. So they have, both the man and the woman have normal vision. So what does that tell you? Is it dominant or is it recessive?
Dominant.
Oh wait, normal is dominant.
Normal is dominant. And X to the little n is for blah blah blah. Okay. Right, so both the husband and the wife have normal vision. So you know she's like that.
But she could have excluded.
But she's a carrier because now the daughter has it.
Yeah, because they don't show, they both got normal eyes. Then again,
Okay.
I don't know how it looks, you know.
So if the child is like that, because it tells you that she is, okay? What is it? Because from the father of this child
Yes.
must have got X to the little n. And can't have come from that father, must have been some other
So she
gene.
cheats twice in this.
I'm listening.
Imagine, because
I know that's not.
if the wife had a child,
I'm not.
it's either him or it's another guy.
The camera.
Like, they don't even need not be another mom. I mean, I don't know.
No, I understand that. But
Hey, never say never.
But she's probably going, I didn't cheat on you.
Yeah.
And he's saying she did. And this is evidence that she must have.
Can it be a mutation now?
No.
Like, can that happen by accident?
Are you rocking on my chest?
No.
It could have.
So, but then now he thinks she cheated, but it was actually.
Because if you consider the history of the haemophilia thing in the British royal family, Queen Victoria was the mutant for haemophilia. She was, because there was no history. There was absolutely no history of haemophilia in their family. And then, if you look at Queen Victoria's children, so her husband was not a haemophiliac. But of the children, a whole lot of the children were haemophiliac. Which gender?
Male.
Male. Good. Definitely male. Because if the father was not a haemophiliac, then the daughters wouldn't have been haemophiliac, but they would have been carriers. Some of them would have been carriers. Half of them would have been carriers. So Queen Victoria herself was a carrier. But the fact that there's no history in her ancestry of haemophilia means that either one of her parents must have had a mutation during their lifetime, or she got a mutation and passed that on. Now remember, it can't be passed on if it's a somatic mutation. So remember, if one of her skin cells or something like that mutated that gene for haemophilia, she would not have passed it on. But if a germline cell, in other words, a cell in the ovaries or the testes, mutates, then the sperm or the ova that are produced could hold that mutation, and it could be passed on. You're all happy, you all understand that. And that's why Queen Victoria's daughter, who married into the Russian royal family, that daughter was a carrier. Didn't you say you do history? No, so that daughter was a carrier. So it was Tsar Nicholas. Tsar Nicholas was normal.
Nikolai.
Yeah. And the Tsarina was the carrier. She was Queen Victoria's daughter, and she carried haemophilia. And therefore, and they had a whole lot of daughters and only one son. And that son was a haemophiliac. Okay, and that was a whole big issue behind the whole Russian Revolution.
That's why Rasputin came.
Because of Rasputin. Because Rasputin claimed a whole lot of things like he could cure the child, and he had a whole lot of influence over the Tsarina. And the people didn't like that. Because he was obviously just...
They thought they were having an affair.
Yes, and they quite possibly were. Anyway, I didn't say that.
So Queen Victoria, her genes mutated.
Either that, or it's actually slightly more likely that one of her two parents had a mutation that they passed on.
And it's not that one of the parents had an affair. Like, that's
Interesting.
Oh. It's possible.
yeah.
Wait, ma'am, so can I mutate now? Like, I just be walking one day and then boom, like my foot does these ones. Or like this.
You have mutations all the time.
Oh,
Everybody has mutations. There's a very high mutation rate. No, but that foot is fully formed.
So it can't
If
be
you have a mutation, it'll be in 1 or 2 cells of that foot. It's not going to be the whole foot. And you're not going to pass it on to your children because your foot doesn't make sperm cells. Okay, you get it? So mutations are happening all the time. I mean, that's what cancer is. An example would be skin cancer. Would be exposure to sunlight, mutations happen, skin cancer happens. That's a mutation. Not going to pass it on to the children. Okay.
So like back in the days when we were still like growing as like little things, like did we like just mutate like one day and then like that's how we just became a bit bigger? And then like it just happens spontaneously. It's not like
No, hold on. What are you saying by we?
Okay, let's just in the world, right? On this earth, like how like everything like was a little something, right? Like a fish.
Okay. Can we leave that until we get on to do evolution?
Okay.
Because it's exactly how evolution occurred.
Oh wow.
Because you've got a whole lot of organisms and one of them has a mutation and that mutation is an advantage. So then that's the thing that is going to be able to reproduce more successfully because it's an advantage. So in the following generation you're going to have more of these ones and less of those ones. And that's how evolution occurred.
And it just happens spontaneously, like.
Yes, and it's random.
Okay, and then the ones that obviously are not advanced by the thing die.
So then,
Because.
Yes,
So
yes,
the
because they
survival
don't
of
have.
the fittest, like die.
That it's exactly what survival of the fittest is. It's exactly that.
like a clownfish one day gave birth to like a baby shark for them to start for sharks to start.
No, say that again. I missed your first
A
sentence.
clownfish, like okay, obviously not a clownfish, but like a clownfish gave birth to a shark at some point for sharks to start living.
Sharks are actually less advanced than clownfish.
So then the other way around.
No, it would be a common ancestor.
But don't fish and fish.
Yeah, it would be fish, and then you get a whole lot of different options, of which some are more advantageous and they are able to survive. But let's leave that until we deal with evolution, because there are a whole lot of things that you have to understand before we get onto it. Tabzikins.
Just a real quick one, man. Does that mean we're related to that fish that has human teeth, or is that just like a different thing?
Have you been looking at Google?
There's a fish that has human teeth.
Yeah, and it's just swimming around. It's living.
Yeah, it's not like a human teeth. If it bites you, you think the human bit you teeth. It's human teeth.
In
No.
real life now.
Yes.
No, it is.
Ma'am, Google
No. Okay, moving on.
Fish.
Okay, yes, Joshua. Okay, guys, do you want to know why we're 70 lessons behind the other class? Because I need to talk. Josh.
So you said that we have mutations happening in us all the time. If that's the case, like why don't I see anything different with me, for example?
Because many of the mutations are internal. And remember, if a mutation occurs in a liver cell for a different eye color, do you understand what I'm saying?
Yeah,
Because
I know what you're saying.
that liver cell has all the genes. So if a mutation in that liver cell occurs for a different eye color, you are not going to suddenly go spoiling purple eyes.
That would be cool.
Does that make sense?
Yeah.
So many of the mutations are in a different spot and it's just one cell. Or 2 cells maybe.
Are birthmarks a mutation though?
Birthmarks.
Yeah, I think so. Yes, yes. Because remember I sent you a thing yesterday and I said this is a nice article for you to read.
I saw it better than it though.
Yeah, man, the article is kind of long.
Yeah.
More than 5 lines there, man. Well, man.
By definition that's an article.
I know.
Because it is more than 5 lines. Okay, so guys do, okay. Now this is a nifty one because the eye color gene in fruit flies is on the X chromosome, but it's dominant. And so far in 6 things, we've done recessive. So it's terribly important that you know that you can do a dominant one. Okay, so those kids who are going, I'm going to carry on with this, and you need to just catch up with your own little lonesome, and I expect you back in 10 minutes. Sprinting. Remember you said to me, quick? Remember? Remember you said that? It was one of your convincing points, yeah?
Why does it keep quick?
I don't know why you're packing,
Oh,
because you're going to be back in 10 minutes.
okay, yes. Yes.
So you said the liver cell has, your liver has like all your cells, right?
No, I said liver cell has all the genes.
And then your
No, where are you going?
So let's say you have brown eyes, but then you have a gene for blue eyes in your liver. Could you take that cell and then like put it in your eyes, like in the face?
Okay, right. Going. Run. Okay. Okay, are we focused? Are we listening? Tugsy.
Yes, this guy.
Okay. In fruit flies, eye color is carried on the X chromosome. The allele for red eyes is dominant over recessive allele for white eyes. Cross a homozygous red-eyed female to a white-eyed male. What is the genotype of the male? Okay. Now, quite obviously, fruit flies then, because they don't tell you any different, have the same sex determination system as we have. Okay, right, so male fruit flies. Okay, so what are the symbols you're going to use, and how far did we get with picking on kids? Carrie, it's yours.
Isn't it,
Go, Papa.
would it be big R, small r, for red eyes and white eyes?
Read the problem.
The allele for red eyes is dominant over its recessive allele with white eyes. Yeah? What's wrong there? That's what I would say.
I'm 100% certain it says it's on the X chromosome. And so the symbols you're using are.
X.
Oi.
Oh,
This could be like a 16-mark question in your matric exam. And you mess it up at the first level.
I think we all fail them, ma'am.
we.
We are not confused. Best we don't be confused.
Ma'am, that's what she said, right?
What?
No, she didn't say that next though.
I think
She
got
didn't
the
say yes.
But you're right there.
Yeah, it's implied.
It's a good.
Yo.
Okay, why is Drosophila underlined?
Because it's a name, but it's a genus thing.
It's a genus name. Good. Okay, and that represents the allele for, and don't you dare do this, white eyes in Drosophila. Okay, so then it says to you that a homozygous red-eyed female Drosophila mates with, so you don't have to say marries here, a white-eyed male, and child behind Kerry. Go.
X, small r, y.
Good. Okay, so gametes, half of them are going to be X to the big R, half of them are going to be X to the little r, half of them are going to be X little r, half of them are going to be Y, and so in a Punnett square,
Wait, ma'am,
what?
doesn't it say homozygous red-eyed female?
Yeah.
Does it?
Yeah.
Drunk as a skunk.
Yo.
Skunks are drunk. That's why they